March 21st, 1918, 4:40 in the morning. The Somme Valley, France. Lieutenant James Thornton of the Royal Artillery pressed his field telephone to his ear, straining to hear anything through the cacophony erupting around him. For 4 hours and 40 minutes, German guns had been pulverizing British positions with a fury unlike anything the war had yet seen. 6,000 artillery pieces, 1,000,000 shells in those first brutal hours. Operation Michael, the German spring offensive, had begun, and in that hellish dawn, Thornton realized something that turned his blood cold. He was blind. His forward observation posts, those critical eyes that guided British guns onto enemy targets, were gone. Overrun, silent. The carefully planned artillery barrage system that Britain had refined over 3.5 years of war had just collapsed. German stormtroopers were pouring through the fog and smoke, and Thornton's guns, powerful as they were, might as well have been museum pieces. Without observers to spot enemy positions, his gunners were reduced to firing blindly into the murk, hoping to hit something, anything. It was a catastrophe. But from this disaster would emerge one of the most crucial innovations of the First World War, born from desperation, improvisation, and the courage of men willing to fly fragile aircraft through storms of steel to become the new eyes of the artillery. This is the story of how Britain's gunners and pilots, working together under impossible conditions, revolutionized warfare itself. The German onslaught that morning was devastating beyond comprehension. General Ludendorff had gambled everything on this offensive, throwing 76 divisions against 26 British divisions holding a 43-mile front. The bombardment wasn't just heavy, it was surgical. German artillery targeted British gun positions, communication trenches, headquarters, and most critically, the forward observation posts where British artillery officers directed fire. These observation posts were the linchpin of British artillery doctrine. Positioned in reinforced dugouts or shell-damaged buildings close to the front lines, observers would watch for German movement, calculate ranges, and telephone coordinates back to the gun batteries miles behind. The system had worked well enough in static trench warfare. But now, as German infantry advanced under cover of fog mixed with poison gas, those observation posts became death traps. By mid-morning on March 21st, dozens had been captured or destroyed. The telephone lines connecting them to the guns were cut by shellfire. Runners couldn't get through the barrage. And suddenly, British artillery commanders faced a nightmare scenario. They had the guns, they had the shells, but they had no idea where to aim them. Major William Fraser of the 52nd Brigade, Royal Field Artillery, watched German troops advancing across open ground less than 2 miles from his battery position. His 18-pounder guns could have massacred them. But without precise coordinates, without someone to observe where the shells were landing and call in corrections, his gunners were as likely to hit their own retreating infantry as the enemy. Fraser later wrote in his diary that he felt a rage unlike anything he'd experienced in the war, not at the Germans, but at his own helplessness. His guns sat silent while British soldiers fell back in disorder. The carefully constructed defensive system was unraveling, but even as the crisis unfolded on the ground, a solution was already taking shape in the skies above. Captain Arthur Harris, flying a Royal Flying Corps reconnaissance aircraft that morning, witnessed the catastrophe from 1,500 feet. Harris, who would later become Marshal of the Royal Air Force during the Second World War, was conducting what should have been a routine morning patrol when the German offensive erupted below him. Through breaks in the fog and smoke, He could see German columns advancing, British positions being overrun, and most tellingly, he could see exactly where German artillery batteries were positioned. Harris understood immediately what the ground commanders could not yet grasp. The observation posts were gone, but observation itself was still possible. It just had to come from above. He scribbled notes on his knee pad marking German positions, and when he landed at his aerodrome near Amiens, he rushed to find the nearest artillery liaison officer. What Harris proposed seemed almost absurdly simple. If the ground observers were blind, let the aircraft be the observers. But the artillery officer he spoke to, Captain Edmund Maitland, immediately grasped the immense complications. How would the aircraft communicate with the guns? Field telephones required wires. Wireless telegraphy sets existed, but they were heavy, unreliable, and most aircraft couldn't carry them. Visual signals could work, but only if both aircraft and gunners understood the same code, and only in good visibility. And even if they solved communication, how would they coordinate fire in real time, with aircraft moving at 80 miles per hour and shells taking 30 seconds to reach their targets? The problem seemed insurmountable. Yet they had no choice but to try. By the afternoon of March 22nd, as German forces continued their advance, the first experimental attempts at aerial artillery spotting began. The Royal Flying Corps had been conducting artillery observation since 1915, but always in a limited, pre-planned fashion. Aircraft would photograph enemy positions, pilots would drop messages in weighted bags to gun batteries, or they would use prearranged signal systems. But what was needed now was something far more dynamic: real-time spotting, immediate corrections, a conversation between aircraft and guns conducted in the middle of battle. Lieutenant Robert Mackay, a pilot with No. 35 Squadron, volunteered for one of the first attempts. His aircraft, an Armstrong Whitworth Fk-8, was a two-seater reconnaissance plane, sturdy but slow. His observer, Lieutenant David Henderson, carried a wireless telegraphy set that had been hastily installed that morning. The set was a Sterling model, weighing over 100 pounds with its batteries and trailing antenna. It reduced the aircraft's already marginal performance, but it could transmit Morse code signals up to 10 miles under ideal conditions. Mackay and Henderson took off at 3 in the afternoon, heading for the sector where the 41st Brigade, Royal Field Artillery, was attempting to slow the German advance. The plan was straightforward in theory. Henderson would spot German positions, transmit coordinates in Morse code, and then observe where the British shells landed, sending corrections until the guns found their mark. In practice, everything went wrong almost immediately. The wireless set began malfunctioning as soon as they reached altitude. The cold affected the batteries. Vibration from the engine loosened connections. Henderson tapped out test signals, but received no acknowledgement from the ground station. Meanwhile, Mackay was flying through increasingly heavy anti-aircraft fire. German forces had brought forward their anti-aircraft guns with the advancing infantry, and the Fk-8, flying low enough for Henderson to observe accurately, made an excellent target. Shrapnel burst around them. Mackay threw the aircraft into a series of sharp turns, trying to spoil the German gunners' aim, but each maneuver made it harder for Henderson to operate the wireless or observe the ground. After 20 minutes of frustration, Henderson made a decision. If the wireless wouldn't work, they'd use the old method. He scribbled coordinates on a message pad, stuffed it into a weighted message bag, and dropped it toward the British gun position they'd identified before takeoff. The bag tumbled down, trailing a long streamer. Henderson watched it fall, praying it would land close enough for someone to find it. It disappeared into a shell-cratered field. They never knew if anyone recovered it. Mackay turned the aircraft back toward their aerodrome, both men feeling the bitter taste of failure. But as they flew back, Henderson noticed something. When British shells did fire, he could see exactly where they landed. The smoke bursts were clearly visible from the air. If he could somehow tell the gunners what he was seeing, guide them onto target, this could actually work. The communication problem remained the critical obstacle. That evening, Artillery and Royal Flying Corps officers held an urgent conference at British Fifth Army headquarters. The situation was desperate. German forces had advanced up to 8 miles in some sectors, the deepest penetration on the Western Front since 1914. British divisions were falling back in confusion. Without effective artillery support, the retreat could become a rout. Major General Herbert Uniacke, commander of Fifth Army's artillery, was a methodical officer who had spent years perfecting British artillery techniques. Now he was being asked to improvise an entirely new system in the middle of a crisis. But Uniacke was also a realist. The old system was broken. Something new had to be tried. He authorized a series of experiments, giving Royal Flying Corps squadrons and artillery brigades permission to develop whatever methods might work. There would be no time for proper testing or training. They would learn by doing, under fire, with men's lives hanging on whether they succeeded. Several approaches emerged simultaneously. Some squadrons tried using colored flares dropped from aircraft to mark targets. Red flares for German artillery, white for infantry concentrations, green for headquarters. It was simple, required no wireless equipment, and could be seen clearly from the ground. But flares were imprecise, could be misinterpreted, and gave away the aircraft's position to every German gunner in the area. Other crews experimented with improved message-dropping techniques, using larger streamers and establishing designated drop zones where artillery officers would watch for incoming messages. This worked better than random drops, but it was still slow, and messages could be lost or damaged. The breakthrough came from an unexpected source. Lieutenant William Sholto Douglas, another future Marshal of the Royal Air Force, was flying with No. 2 Squadron when he and his observer developed a hybrid system that combined multiple communication methods. They would use wireless telegraphy for initial contact and basic information, but supplement it with a visual code system using the aircraft's maneuvers. Banking left meant shells were falling left of target. Banking right meant adjust right. Climbing meant shells were overshooting. Diving meant they were falling short. A full circle meant shells were on target, fire for effect. It was crude, but it worked even when the wireless failed. And crucially, it allowed for rapid corrections. A skilled pilot could communicate a correction in seconds, far faster than encoding and transmitting a wireless message. On March 24th, Douglas and his observer, Lieutenant Arthur Cunningham, put this system to the test over the village of Bapaume, where German forces were consolidating for another push. They made contact with the 63rd Brigade Royal Field Artillery, whose commander, Colonel James Burnett, was willing to try anything. Douglas flew his aircraft to a position where he could see both the German concentration and the British gun flashes. Cunningham transmitted the initial coordinates via wireless. The guns fired. Douglas watched the shells land 400 yards short. He immediately put the aircraft into a climb, the signal for overshoot. He held the climb for 5 seconds, then leveled out. On the ground, Burnett's officers interpreted the signal correctly. They increased the range. The guns fired again. This time the shells landed 200 yards short. Douglas climbed again, less steeply. Another adjustment. Another salvo. The third salvo landed directly among the German positions. Douglas threw the aircraft into a full circle, the signal for fire for effect. Below, Burnett's entire brigade opened up, all 18 guns firing as fast as the crews could load. For 3 minutes, high-explosive shells rained down on the German assembly area. When the smoke cleared, Douglas could see the attack had been disrupted. Vehicles were burning. Infantry were scattering. It wasn't a decisive victory, but it was proof the system could work. Word of Douglas's success spread quickly through both the Royal Flying Corps and Royal Artillery. Over the next few days, as the German offensive continued, more crews adopted and refined the technique. But the work was extraordinarily dangerous. To observe accurately and communicate effectively, aircraft had to fly low, typically between 1,000 and 2,000 feet. At that altitude, they were vulnerable to everything. German anti-aircraft guns, machine guns from the ground, and increasingly, German fighter aircraft that recognized the reconnaissance planes as high-value targets. The Fk-8s and Re-8s used for artillery spotting were no match for German Fokker and Albatros fighters. They were slower, less maneuverable, and their only defense was the observer's Lewis gun. Losses mounted rapidly. On March 26th, No. 35 Squadron lost 3 aircraft in a single day, all shot down while conducting artillery spotting missions. Lieutenant Mackay, who had flown one of the first experimental missions, was killed when his aircraft was hit by anti-aircraft fire and crashed behind German lines. His observer, Henderson, survived the crash but was captured. The psychological strain on the crews was immense. They were flying multiple missions per day, each one lasting 2 to 3 hours, constantly under fire, operating equipment that frequently malfunctioned, and knowing that every mission might be their last. Captain James McCudden, a highly decorated fighter pilot, later wrote that he considered the artillery observation crews the bravest men in the Royal Flying Corps. Fighter pilots chose when to engage. Observation crews had no choice. They had to fly their assigned sectors, maintain steady courses for observation, and stay in position even when under attack. But the system was working. By early April, as the German offensive began to lose momentum, British artillery had regained much of its effectiveness. The combination of aerial spotting and improved ground-based observation, as some forward positions were re-established, allowed British guns to deliver devastating counter-battery fire. German artillery batteries that had advanced with the infantry suddenly found themselves under accurate fire from British guns they couldn't see. The psychological effect on German troops was significant. They had grown accustomed to operating under British artillery fire during the years of static warfare, but this was different. Shells seemed to find them wherever they moved. Concentrations were broken up before attacks could be launched. Supply columns were hit on roads they thought were out of range. The Germans were experiencing what the British had suffered in the war's early years, the feeling of being watched from above, of having no safe positions. German commanders began to recognize that British aircraft weren't just conducting reconnaissance. They were actively directing fire. German anti-aircraft defenses were reinforced, and fighter patrols were increased specifically to hunt the British observation aircraft. But by then, the techniques were too well established to be easily suppressed. The evolution continued throughout April and into May. Wireless equipment improved. Ground stations became more efficient at receiving and interpreting signals. New code systems were developed that allowed for more complex communication. Artillery brigades began assigning specific liaison officers to work with Royal Flying Corps squadrons, creating permanent partnerships between air and ground units. These officers learned to think like pilots, understanding the limitations and capabilities of aircraft, while pilots learned artillery terminology and procedures. One particularly effective partnership developed between Major Fraser, the artillery officer who had felt so helpless on March 21st, and Captain Edward Manick, a rising ace pilot who volunteered to fly observation missions despite being primarily a fighter pilot. Manick had the flying skills to evade German fighters while maintaining position for observation, and Fraser had the artillery expertise to make maximum use of the information Manick provided. Together, they developed tactics for what they called hunting shoots, where Manick would search for German artillery batteries, and once located, Fraser's guns would engage them in rapid succession, trying to destroy multiple batteries before the Germans could react. On April 17th, during fighting near Ypres, Manick and Fraser conducted a hunting shoot that destroyed or disabled 7 German artillery batteries in a single afternoon. It was a remarkable demonstration of how far the coordination had evolved in less than a month. The technical innovations continued as well. Engineers developed lighter wireless sets specifically designed for aircraft installation. New antenna designs improved signal reliability. Ground stations were equipped with directional receivers that could track aircraft by their transmissions, helping to coordinate multiple observation missions simultaneously. Perhaps most importantly, a standardized code system was established across the entire British Expeditionary Force, ensuring that any artillery observation aircraft could work with any artillery brigade. The code used a grid reference system combined with clock code for corrections. The target area was divided into a grid, with each square assigned a letter-number combination. The aircraft would transmit the grid reference, then use clock code to indicate where shells were landing relative to the target. 12 o'clock meant shells were landing beyond the target, 6 o'clock meant they were short, 3 o'clock meant right, 9 o'clock meant left. By combining grid references with clock code, observers could guide guns onto targets with remarkable precision. The system was simple enough to be learned quickly, yet sophisticated enough to handle complex fire missions. By June 1918, aerial artillery observation had become standard practice in the British Expeditionary Force. What had been born from desperation in March had evolved into a comprehensive doctrine. Artillery brigades now routinely operated with attached Royal Flying Corps observation flights. Mission planning integrated air and ground elements from the start. Pilots and observers received artillery training, while artillery officers learned basic aviation principles. The impact on battlefield effectiveness was profound. British artillery, which had been rendered nearly impotent on March 21st, was now more lethal than ever. Counterbattery fire became devastatingly effective. German artillery losses increased dramatically. British guns could respond to targets of opportunity within minutes of them being spotted. The flexibility this provided to British commanders was revolutionary. Artillery was no longer just a tool for pre-planned barrages. It had become a responsive tactical weapon that could be directed against emerging threats in real time. The Germans attempted to develop similar capabilities, but they were hampered by resource shortages and the fact that they were learning from a position of weakness. The British had been forced to innovate by crisis, and that urgency had driven rapid development. By the time the German military recognized the importance of aerial artillery observation and began implementing their own systems, the British had months of experience and refinement. The human cost of developing these techniques was substantial. Between March and November 1918, the Royal Flying Corps and its successor, the Royal Air Force, lost over 400 aircraft conducting artillery observation missions. Casualty rates among observation crews were higher than among fighter pilots. Many were shot down by anti-aircraft fire or German fighters. Others crashed due to mechanical failures, often caused by the extra weight and vibration of wireless equipment. Some were lost to simple exhaustion. Pilots and observers pushed beyond their limits by the demands of flying multiple missions per day in combat conditions. Yet the crews kept flying. They understood the importance of their work. Every successful fire mission meant British infantry faced fewer German shells. Every German battery they helped destroy saved British lives. Lieutenant Henderson, who had been captured in March, later returned to Britain in a prisoner exchange. He immediately volunteered to return to observation duties, despite having every reason to request a safer assignment. When asked why, he simply said that the work mattered more than his personal safety. That sentiment was common among the observation crews. They had seen what happened when artillery was blind. They had watched British soldiers die because guns couldn't support them, and they were determined that would never happen again. The techniques developed in those desperate months of 1918 transformed warfare permanently. The principle of aerial observation directing ground fire became fundamental to military doctrine worldwide. In the Second World War, forward air controllers would perform the same function, using radio communication instead of wireless telegraphy and Morse code, but the essential concept remained unchanged. Aircraft as the eyes of artillery. Real-time communication between air and ground, coordinated fire control based on aerial observation. These were the foundations of combined arms warfare, and they were established by British gunners and pilots working together under impossible conditions in the spring of 1918. The German spring offensive ultimately failed. By July, the German advance had been halted, and British and Allied forces began their own offensives that would lead to victory in November. Aerial artillery observation played a crucial role in that success. British artillery, blind and helpless in March, had become a precision instrument by summer, capable of delivering devastating fire wherever it was needed. The innovation born from catastrophe had changed the nature of warfare itself, proving once again that necessity drives invention, and that courage and ingenuity can overcome even the most desperate circumstances. The partnership between Britain's gunners and pilots, forged in the fires of crisis, had revolutionized the battlefield and saved countless lives. Their legacy would endure for generations, a testament to what can be achieved when skilled professionals refuse to accept defeat and instead create solutions that transform their entire field of endeavor.